Um, Good afternoon, guys. Sanbona. Builu Makeva. Today we'll be focusing on representation or interpretation of graphical interpretation of derivatives. So we'll be interpreting the graphs based on derivatives. I hope you still remember on what is the derivative. Derivative, we use it as the equation, or we use it as the gradient of the tangent. So how can we use the derivative? We can use the value of a derivative at a specific point on a function to establish whether the function is increasing or it's decreasing at that point. Let's assume that, or let's just take where if our f prime of a is greater than u0. What does this mean? It means that our function or our f prime of a is bigger than u0, meaning it's positive than u0. I hope you understand that. Then if what this means, that then our function, which is f, now remember we are using f prime, which is the derivative, but we're interpreting what the function f is increasing at x is equal to a. Hope you understand that one. Let me just draw a graph for you. Just gonna show the x-axis only. This is gonna be our tangent. Just gonna draw the tangent here, where we have a point of a here. This is our x values. X-axis, gonna have y values. I'm not gonna show our y values here, but now when you are looking at your graph from this point, going up, going up, going up, going up, your function is increasing. From here, going up, going up, going up, going up, function is increasing, meaning your f prime of a is greater than money than 0. I hope you see that one. I hope you see that one. Meaning our f is increasing at a is equal to 0. Let me just do another function here, just another representation of graphics, where now our point here, or our tangent, is on top of our graph. But now when you also look at this graph from this here, going up, going up, going up, is increasing, meaning our f prime of x is greater, not equal to, it's greater, inkulu kunobani, kuno 0. Then if our f prime of, okay, just call it x here, if our f prime of x is greater, inkulu kuno 0, this means our f is increasing. At just this x is equal to a, at x is equal to a, just call this x is equal to a. Now let's look at the decreasing part of it. Now the decreasing part of it, if our f prime of a, which is x, is less than now. This is less than 0, meaning lokhu kuncane kuno 0. U0 it's nkulu kunalokhu. Chaza ukuthini lokho? Chaza ukuthi our f is decreasing at x is equal to 0. X is equal to a, sorry, and x is equal to a, which is a specific x-intercept, where x is equal to a. If we can do our graphical representation, we draw our tangent, which is our x-intercept, our x Cartesian plane. There's x here, which is a here, and this is our function. If you look at our function here, starting from at the top, you're going down, you're going down, you're going down. Our function is decreasing, going down, going down, going down. Our function is decreasing, meaning our f prime of a is less than 0. Therefore our f is decreasing at x is equal to, sorry about that, a. I hope you still get that one. I hope you still get that one. Let me do another one. Do our tangent here. This is just the example, the representation of the graphs, where you need to identify that your graph is decreasing or it's increasing. This is point at x is equal to a. Now when you look at your graph from here, going down, going down, going down, so from the top going down, it's decreasing. From here going here, it's increasing. From here going here, it's increasing. From starting at the top, going here, going here, going here, decreasing, top, decreasing. I hope you see the difference. So f prime of a, which is a specific point, it's less than 0. So our f is decreasing at what? At x is equal to a, which is the specific point that is given at that particular moment. I hope you do get that one, guys. I hope you still remember that f prime of a is equal to the gradient. I hope you remember that. If f prime of a is equal to the gradient, meaning your gradient at that particular point is greater than 0, meaning your function is increasing. If f prime of a it's greater inkulu kuno 0, your function is increasing. If your f prime of a it's greater than 0, it's increasing. So if your f prime of a is less than, it's negative, then 0, meaning gradient yakhe incane kuno 0, meaning your function is decreasing at a specific point. That is very, very, very important. Coming to this one now, if must make sure in your hand you know that f prime of just gonna use f prime of a is a gradient. F prime is where we're saying derivative ilingana nani ne gradient. So f prime, so we write it, if f prime of a ilingana no 0 now, now it's equal to 0. It's equal to 0. Ilingana no 0. It's not greater, it's not less than, but is equal to 0. Our f prime of a. Now if kunjalo, then f has a stationary point. Is stationary, something that is stationary, intemile. Stationary point is a point where it's just standing at x. At x is equal to bani a. Let me just show the graphics before we move on. Stationary point is a point that is here where the gradient is equal to 0, where this is our point A. This is gonna be one of our tangent when it's cutting here. When the gradient cut here, the x is equal to 0. Our tangent when it's cut here, the gradient here it's 0. The gradient here, I hope you know what is the equation of a horizontal line. The horizontal line, the gradient here it's 0. It's y is equal to that specific number that you have. So the gradient here is equal to 0. The equation of this is just y is equal to a specific number that we are going to have. So the gradient here is equal to 0, which is a stationary point. We also call this point a turning point, where our graph is turning, because we're going to use this thing. It's very important that you understand what the gradient here at this point it's equal to 0, where our graph is turning, where a point is stationary here. It's not here, it's not here, but it's here, where our tangent here it's what? It's horizontal. Very important. Now let me tell you something else again. Go to something point. So if the function is increasing before now, if the function is increasing before the stationary point, which is this point, and stationary point, and decreasing after the stationary point, or vice versa. Then f, which is our function, is set to be both increasing and decreasing at the stationary point. it's the stationary point. Let me just in the graphics, writing the graph, explaining the statement that I just wrote here. Our graph, this one, sorry about that. Our graph is this one. We have a point which is A here. We have our tangent here, which is our gradient is equal to 0. Now what you need to understand from the statement here, from here to this side, from here going up, going up, going up, the function is increasing. From here to this side, our function is increasing, and then it reaches the stationary point. When it's reaching the stationary point, now going this side, now from top to bottom, now it's decreasing. That's what this statement is saying. So now what is this thing saying? At f function is increasing and decreasing also where at x is equal to a. From this side going up, yeah, increaser, my figure allowed to the stationary point, going down is decreasing. Very important to understand that, because when you have to interpret your graph, when they say tell me where is your graph is increasing, where is your graph is decreasing, you must understand these things. Very, very important. Let me just show the other one here. FA here, FA here, our tangent here, where our gradient is 0. Now what you need to understand, from this side going here, from this side going this side, our function is increasing. Now from this side going this side, from the top going down bottom, here decreaser, figure to the stationary point, increasing. So from this side going down, going down, going down, from this side going down, going on this side going down, and then it's decreasing. I hope you understand that one. From here going down, going down, going down is decreasing. This is what this statement is saying. I hope you understand it, guys. Go through the video, pause the video, first go back to the video, pause it, make sure you understand it. It's very important then you understand the interpretation of the graphs, because when you go to the graph you must interpret your graphs. Let's go to another point. Now if the graph is increasing before and increasing and after the stationary point then f is increasing, at the stationary point. So if the graph is increasing before and after the stationary point, then the function is increasing at the stationary point. Let me just show the graph of what the statement is saying here. Just have your x value, x-axis here. You have a function going like this here, which is going to be our tangent here. This is our tangent where the graph cuts. This is our stationary point here. That's where our graph changes the direction. This is our turning point. So this graph goes here, goes here, goes here, then reaches this point, and also goes increasing. So from down here going top, coming to the stationary point, from this stationary point also going top. So yeah, it's increasing here, and also it's increasing here, where a point here ubani OA. So our f is increasing at x is equal to OA. I hope you do understand that one. Let me just do the opposite now, where our function now, this thing, but now it's decreasing now. So if the graph is decreasing, before and after the stationary point, then the f function, which is the f function, is decreasing at stationary point. What is this statement saying? It's just saying here graphically. Okay, let me just do it as a Cartesian plane like this. Just saying like this. At this point here, where it's our turning point, where our tangent, where our x is equal to, where our f prime of x is equal to 0. So now what is happening here, from here function here to our f, from top going down, it reaches this point, also going down after that point. So here decreasing from here going down, also after from here it's also decreasing. So our f is decreasing at, call it a, at x is equal to a. I hope we do understand the graphics and everything that is going on here in terms of the interpretation of our graph. Thank you so much, guys, for listening to this video. It's a very important video. Interpretation of the graph. You must know how to interpret the graph. It's very important to interpret the graphs, and it's part of you knowing your graph, interpreting them. So thank you so much for listening. Makebalo. See you now. Thank you.